Good morning. Today we're going to do a introduction to vectors in our O-level math series by SC2K. So now, what is a vector? So a vector is a type of number, a quantity more actually, that has both magnitude as well as direction. That means, for example, force is going to have a unit magnitude, and how long it is, how great the force is, 3 Newton, for example, and a direction in which is applied. Now, in relation, a scalar quantity is one that only has magnitude and no direction. So please bear in mind, a vector, in addition to the magnitude, you will always have a direction. Here I call it a type of number. Actually, it's a type of quantity. All right. Now vectors are usually expressed as an arrow over a starting and end point. So see here, from A to B. So from A to B, so this is the start point A and the end point B. So we write it this way. Now the value of vectors are usually expressed in bold when printed. So in your exam paper, it's going to see this in bold or in comparison, and with a line below when handwritten. So, but when you write your answer, because you can't bold your handwritten answer, you're going to write in this way, or with this curly line below. Now, some rules: a vector of the same length, that means it has the same magnitude. Okay, parallel to another but opposite in direction. So it has the same magnitude. So you see the A is the magnitude. The magnitude is the same, but because the direction is different, this is A and this will be negative A. It has the same magnitude, but it has different direction. Now with a parallel vector, that means their direction is exactly the same with twice the magnitude. We'll have twice the, so A, half A, 2A. So basically the only difference between these three is they are all in the same direction. They are still parallel to each other, but their magnitude is different. I think quite easy, right? All right, same thing. Now I'm going to talk to this about coordinate vectors. Basically, is putting the vector concept into your coordinate geometry. So now, what is this 5, 3? That means a vector is going to move from its start point 5 unit in the x direction, moving right in the x direction, and 3 unit upward in the y direction. So here I have expressed it here in this picture. So we start from 1, 1, 5 unit in the right direction. So it's now coming to here, and then 3 unit upwards. So what is this point? This point is now 6, 4. If you take 1, 1 plus 5, 3, you get 6, 4. So this is your new, this is your end point. So this vector, we call it a coordinate vector. And this is how you write your coordinate vector, 5, 3. Okay, next. Position vector. If your vector starts from 0, which is the origin, 0, 0, the origin, then we can also call this a position vector, because the vector 3, 2 will correspond directly with the coordinates of the actual point, of the endpoint. And that's why we call it the position vector, because it starts from your origin. If it's too fast, you can always play back the video, come back and try to understand what I mean. There'll be some example later on, so do not worry. Now, how to solve vector question? Usually, the question will ask you to say, what find AB, find AC, and it's not given to you, so you need to add two vectors together or minus vectors. So now I want you to have this thinking that it is a journey. Vector is a journey where you have to choose your start point first and your end point. Let's take for example DB. Now DB is from here to here. Let's go back first. Let's see this line DB. So start point is D, end point is B. So to do this, we start from D and we go B. Now there's a lot of possible ways to reach DB. To reach the endpoint B from D. I can do this, which is the blue line. I can go to A first, and then I go to B. Now if I do that, that will be DA plus AB. So if I have the vector DA and I have the vector AB, I just need to add these two vectors together and you'll give me vector DB. Otherwise, alternatively, I can also use C. That means I can go to C first before I reach B. So I can add DC plus vector CB. If I have either one of these, or if I have both of these, then I can add them together and I will still get vector dB. And the answer will be the same as the my blue path. It will give you exactly the same. As long as you don't make any mistakes in between, you have exactly the same vector. Alternatively, you can also make one long way. For example, this red one, DC, go to P, so CP, and then add PB. Let's just say I don't have AB or I don't have CB, and then I have CP and PB, so I can do this too. DC, CP plus PB. So all these paths will give you the same vector dB. So I hope you have this concept and you'll be a lot easier for you to do your vectors question in this way. Our next point that will always come out, almost always come out in your vector question, but it's a bit harder, is your proving question. They will always almost ask you to prove that 3 points form a straight line, or that the following point lie in a straight line, etc. etc. So how to prove this? Now let's just take these 3 points for example: A, B, and C. Okay, first point, how to prove collinearity. That means how to prove that they are on a straight line. All these are just different words which means the same thing. So you must be able to see that that's just different way of asking the same thing in your exam paper. Choose two vectors with a common point among 3 points. So first one, let's just say I choose the point B. Now if I choose the point B, then I'm going to use vector AB and vector BC. Can you see that A B and BC has a common point B as a vector? Yes. So if I can prove that AB is equal to KBC, now K is just a number. It could be 3, it could be 2, it could be 1/3, it could be 1/4. As long as it's a number, okay, it's a multiple. So basically, I'm trying to say that AB and BC are factor multiple relationship. As long as I can show this or prove this, then I can show that A, B, and C lies on the straight line, or they are collinear. And alternatively, I can also use A as the common point. If I use A as the common point, then I can use vector AB and vector AC. Okay, the K again the K can be any number as long as I can prove it. So they are factor multiple relationship. Or I can choose C. So if I choose C, then you'll be using AC and BC. Okay, let's do one example to so that's easy for you to understand what I'm saying. Let's just say that it's given that AB is 2A plus 2B and BC is 3A plus 6B. Now I need to prove that A, B, and C are collinear. How am I going to do it? Now, this will be what it looks like. So, first thing, let's recall back our proving collinearity instruction. First, choose two vectors with a common point. So now I'm just going to choose the first common point. Let's choose A first as the common point. Now, if I choose common point, pause the video first, think what is the vector I'm going to get, and then you restart and see if you are correct. Okay? Now, the vector I'm going to choose, if I choose A as the common point, is A, B, and A, C, because A is my common point. Now, AB, I know. AB is A plus 2B, but I do not know AC. Now, how to get AC? Am I right to say AC is from A to C? Isn't it A plus B, AB plus BC? Because you see, remember the journey thing? Yeah, the vector journey concept. So it's AB plus BC, which I have. So I'm just going to add them together. So A plus 2B, again, is handwritten. So I need to put a squiggly line below. Plus 3A plus 6B. And I'm going to get 4A plus 8B. And this is my AC. So let's try to prove that they are in factor multiple relationship. It's always more pleasant to write the bigger one or the seemingly bigger vector on the right. So AC is equal to 4A plus 8B. Let's start with this first. Now, if then I check AB, AB is A plus 2B. Oh, it looks like I can just take out 4. If I take out 4, I'm going to get A plus 2B. Now, A plus 2B, recall back, is actually your AB. So I can say that is 4AB. So AC is 4AB. Isn't this a factor multiple relationship? Oh, where your K this time is 4. Of course, if you reverse it and you put AB on the left, you're going to get 1/4. All right, so no matter what, as long as it's a number here, it works. But if you have like extra things behind, plus something or minus something, then it doesn't work. That's not a factor multiple relationship already. Okay, so now I'm just going to erase what I have done. I'm going to use another common point. Instead, let's choose B as the common point now. Since I think most students will identify the middle point as a common point instead, which is directly given to you. It's easier also, since it's already given to you. So now I going to choose B as the common point. So the vector I'm going to use is AB and BC, which is already given to me. So it saves a lot of work. In fact, this is the best strategy because you don't have to do extra, a lot of one extra steps. So I'm going to start from the one that looks bigger, BC. 3A plus 6B. If I take out common factor 3, it's going to become A plus 2B. Again, this look exactly like AB, which is AB. So 3AB. So again, BC equal to 3AB. Oh, in case I forgot, you need to write a proving statement later on. So let's just say, then we write, since BC is equal to 3AB, comma, therefore A, B, and C are collinear. Okay, I hope this is clear enough for you. If not, just repeat the video and watch it a few more times. Okay, let's go to the next part. Let's do an actual exam example. Now, in the diagram, OAB is a triangle. Yes. P is a point on AB. Let me see AB. Yes, it's a point on AB such that AP is equal to 1/3 AB. Now, AP is 1/3 AB. So if this is 1, this would be 2 because it's 1/3 the whole thing. Yeah. So this is ratio of here to here is 1:2. So the whole thing is 3. OA is A to OB is to B. Okay, fine. OP in terms of A and B. OP now, this. How to go from O to P? I need AP. No matter what, I need either AP or BP. So I would need the whole of AB first. Let's find AB. Now AB would be AO, right? Journeying from A to O, then going to B. Now OA I know, but I don't know AO, but it's just the reverse. So it's minus or negative A plus 2B. Of course, you can also write as 2B minus A. Now this is my AB. Now AB is this. What is my AP? Recall AP is actually 1/3 of AB, which is actually given. So it will be 1/3 of everything. So I can actually just put 1/3 in front. 2B minus A. So this is my AP. Now, so if I want OP, is OA plus AP. So it's A plus 1/3 bracket 2B minus 1/3 A equal, I think quite no space below already, equal Just simplify. I think this is not so hard for you. No, this is one. Why I put one third here? I haven't opened the bracket. So after I open a bracket, it will become one third, negative one third. So a minus one third is two third. A plus two third B. Oh, very nice. So it's just two third A plus B. Yeah, two third A plus two third B. Correct. So this is my OP. I found my OP. Okay, so this is my answer for OP. Next, let's just say there's a second point D lies on OP such that OD is equal to. Okay, so I'm just going to mark here that this is D. So OD is MOP. Okay, and so M must be a fraction, and BD is where? Oh, BD, this one. I'm sorry, just please treat it as a straight line. O BD is KA. K of A. How can BD be KA? Oh, oh, is lies on OP produce, so it should be further. It's not on OP itself. I'm sorry, I read the question wrongly. Let me erase this. Sometimes it's important because it doesn't make sense. Now, that means I produce this longer. Alamak. Just pretend it's a straight line, okay? So let's just say your D is here. Now why I know why is it roughly here? Because they say this is A. This is KA. You see, if it's KA, that means it must be parallel to A. This vector here. So at least it looks almost parallel to it. Okay, so this is KA. And then this is your D. Okay, find the value of M and the value of K. Fine, fair enough. Now, P give you this. Oh, I need my OP. I forgot what's my OP. I mean, I need to go back and read my OP. My OP is 2 third A plus 2 third B. Okay. Let me just write it down first. OP is 2 third A plus 2 third B. Okay. Now, this is your vector OP. Now, if since it lies along, so it's MOP. Okay. OD is this. KA is BD. OD is okay. Fair enough. Let's do this. Now, if I want to find OD, if let's just say I want to find OD, am I right to say that OD is equal to OP? No. Sorry, and erase. Is equal to OB plus BD. So OB is 2B and BD is KA. Right? And this is OD. Now I already know what is OD. I mean, I already know a part of OD in terms of M. If I were just to multiply M in, okay, let me just write MOP here. Okay, MOP. In case it looks like mop, MOP. So OP, now MOP is 2 third A plus 2 third B. Go to 2B plus KA. Now just multiply in, so it's 2 third M. A is your vector, so there's a line, plus 2 third M B equal to 2B plus KA. Now, because this is vector, you can actually compare the respective vector. So I can compare the coefficient so-called of A, vector A, and compare the coefficient of vector B. So I'm just going to write here comparing vector. So K would be 2 third M. And the other one is 2 2/3 m, right? Both of them are the same, right? Is equal to 2. So in this case, let's find m first. Let's call this equation 1 and equation 2. Okay, so from here, 2/3 m is, so m is equal to divide by 2/3, so 3. So m is 3. Okay, so sub m equal 3 into 1. So k equal to 2. So both are 2. No, m is 3 and k is 2. Okay. Part 3, where we come to determine if they are parallel, right? So you want to prove whether two lines are parallel or two vectors are parallel, it must be in a it must be a factor multiple relationship. Oh, it's the same thing. It's just that there is no common point now. But you want to prove that they are all on a straight line, then you have to prove that it has a common point. That's the only difference. So W is a point on OA such that OW, where is OW? OA, on OA. So let's just say it's somewhere here. OW to WA is 3 is to 1. So here is 3. Let's just say this is W. So here is 3. Here is 1, right? OW to WA. Yes, 3 is to 1. Using vector, determine if OB equal. Okay, so let's OB we know. So we don't care about OB, but I want WP. Where is WP? WP is this line. Okay. Now do not judge by observation. It is not, or it cannot be taken as proof. Now we have to find WP then. Since we already know OB, so now let's find WP. Now if you want to find WP, I would need to start from W. So easier to use the WO plus OP since we already know OP in the first part. Now, what is WO? WO is the reverse of OW. Now, what is OW? Or maybe we switch it to AO first. So we can say that this is 3/4 of AO plus OP. 3/4 of AO 3/4 of AO. AO is minus A. So 3/4 of AO is just negative 3/4 A. And then OP is, I forgot. Let's go back. 2/3 A plus 2/3 B. So is plus 2/3 A plus 2/3 B. Okay, let's add that together. 2/3 minus 3/4. Common ground 12. Times 4 times 4, 8. 8 minus 9. So it's negative 1. Negative 1 over 12A plus 2/3 B. Now, if you try to put them, this is WP. If OB, you see OB, the component is just 2B. There is no component A. So they cannot be in a multiple factor relationship. So we can just write from here. Since OB is not equal to KWP, therefore they are not parallel to each other.